According to the 2020 National Electrical Code, the use of number 14 nm cable to feed a bathroom light that is mounted 3 feet above the wall switch is legal. The specific section of the NEC to examine is 210.52. This section deals with dwelling unit receptacle outlets and more specifically 210.52C2, which addresses feeders. It states that where a switch or overcurrent protective device is located at the point of attachment of the fixture, not more than 4 feet of the supply branch circuit, conductors shall be permitted between the last outlet and the switch or overcurrent protective device. In the described scenario, the light is mounted 3 feet above the wall switch. Given this distance is less than 4 feet, the use of number 14 nm cable to feed the light is permitted by the NEC under this specific condition. It's crucial to understand the nuances of this regulation. The allowance for a short run of smaller gauge wire, like number 14, is contingent upon the presence of an overcurrent protective device, such as a circuit breaker, being located at the point where the fixture is connected. This protective device is designed to trip and interrupt the circuit in the event of an overload or short circuit, thereby preventing damage to the wiring and reducing the risk of fire. The rationale behind this exception lies in the limited length of the number 14 cable run. Because the run is short, the potential for a significant overload to occur before the overcurrent protected device trips is minimized. The shorter length also reduces the likelihood of a sustained fault current that could cause the number 14 cable to overheat and potentially ignite nearby combustible materials. However, it is vital to recognize that this exception is very specific and applies only to the situation where the distance between the fixture and the switch or overcurrent protective device is no more than 4 feet. In any other circumstance, the general rules regarding conductor ampacity and overcurrent protection must be followed. These rules typically require that conductors be sized according to the anticipated load and that the overcurrent protective device be rated no higher than the ampacity of the conductors. In the case of a 20 amp circuit, number 14 AWG wire is typically not permitted for general use, as its ampacity is only 15 amps according to NEC table 310.16. The exception provided by 210.52C2 is a limited allowance for a specific scenario, not a blanket exception to the general wiring rules. When interpreting and applying the NEC, it is essential to consider the entire context of the installation and all applicable code sections. It is also crucial to consult with a qualified electrical inspector or engineer if there is any doubt or uncertainty about the code requirements. An electrical inspector may have a different interpretation of the code, or they may be considering other factors that are not immediately apparent. It is always best to have a clear understanding of the code requirements and to ensure that the installation complies with all applicable regulations. In addition to the specific requirements of 210.52C2, it is also important to consider the general requirements for bathroom wiring. Bathrooms are considered wet locations, and therefore, all electrical equipment and wiring must be suitable for use in wet locations. This means that the equipment and wiring must be protected from moisture and corrosion. Ground fault circuit interrupter, or GFCI, protection is required for all 120 volts, 15 and 20 amp receptacles installed in bathrooms. GFCI protection is also often required for lighting circuits in bathrooms, depending on the local electrical codes. The purpose of GFCI protection is to protect people from electric shock. A GFCI is a device that monitors the current flowing through a circuit and quickly interrupts the circuit if it detects a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. Ground faults can be very dangerous and can cause serious injury or death. GFCI protection is an important safety feature that can help to prevent electric shock in bathrooms. Furthermore, it is important to ensure that all wiring connections are made properly and that all electrical equipment is properly grounded. Improper wiring connections and grounding can create electrical hazards and increase the risk of electric shock. When working with electricity, it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electric shock. To summarize, while the use of number 14 nm cable for a short run of up to 4 feet from the switch or of a current protection to the light fixture is permitted under NEC 210.52C2, it is crucial to ensure that all other applicable code requirements are met. This includes proper GFCI protection, suitable wiring methods for wet locations, and correct wiring connections and grounding. If there is any doubt or uncertainty, it is always best to consult with a qualified electrical inspector or engineer. It's also important to consider the overall circuit load. Although number 14Y may be acceptable for the short run to the light, the rest of the circuit must be wired with conductors rated for the 20 amp of a current protection device. This means number 12 AWG wire would be required for the rest of the circuit. Always ensure that wire nuts and other connectors are properly sized for the conductors being joined. Using the wrong size connector can lead to loose connections, which can cause arcing and overheating, creating a fire hazard. Also, be sure to properly support the NM cable. NEC 334.30 requires NM cable to be secured within 12 inches of cabinets, boxes, or other terminal fittings and supported at intervals not exceeding 1/2 feet. This prevents the cable from sagging and potentially being damaged. When running NM cable through bored holes in wood framing members, ensure that the holes are drilled in the center of the framing member and are not too close to the edge, as this can weaken the framing member. Also, install bushings or grommets where the cable passes through metal studs or framing to protect the cable from abrasion. In the specific case of a bathroom, be mindful of moisture and humidity. Ensure that all electrical boxes are properly sealed and that any openings in the boxes are closed with appropriate plugs or sealant. This will help prevent moisture from entering the boxes and corroding the wiring connections. It's also important to consider the location of the light fixture in relation to the shower or bathtub. NEC 410.10D specifies the clearances required for luminaires light fixtures installed near bathtubs and showers. Make sure the fixture is located outside of the restricted zone, or that it is specifically listed for use in wet locations and is suitable for the intended installation. Remember that electrical codes are constantly evolving, and it's essential to stay up to date with the latest requirements. Consult the most recent edition of the NEC and any applicable local amendments to ensure that your electrical work complies with all current regulations. If you are unsure about any aspect of electrical wiring, it is always best to seek professional assistance from a qualified electrician. Electrical work can be dangerous, and it's important to prioritize safety above all else. Furthermore, be aware of the specific requirements for our side protection in bathrooms. Arc fault circuit interrupters of size are designed to detect dangerous arcing faults in electrical circuits and to interrupt the circuit before a fire can start. Many jurisdictions now require side protection for all branch circuits that supply outlets in dwelling units, including bathrooms. Check your local electrical codes to determine whether side protection is required for your bathroom lighting circuit. When selecting electrical equipment for your bathroom, make sure that it is listed by a recognized testing laboratory such as UL or ETL. Listed equipment has been tested and evaluated to meet safety standards and is more likely to perform reliably and safely. Also, be sure to follow the manufacturer's instructions for installation and use of all electrical equipment. Failure to follow the manufacturer's instructions can void the warranty and can also create safety hazards. Before starting any electrical work, always turn off the power to the circuit at the breaker panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. This will help prevent electric shock. When working with wires, always use insulated tools. This will help protect you from electric shock if you accidentally come into contact with a live wire. Wear appropriate personal protective equipment, such as safety glasses and gloves, when working with electricity. This will help protect your eyes and hands from injury. Be aware of your surroundings and avoid distractions when working with electricity. It's important to focus on the task at hand and to avoid making mistakes. If you are working in a damp or wet environment, take extra precautions to avoid electric shock. Wear rubber boots and gloves, and make sure that the area around you is dry. If you are not comfortable working with electricity in a damp or wet environment, it is best to hire a qualified electrician to do the work. After completing any electrical work, thoroughly inspect the installation to ensure that it is safe and compliant with all applicable codes. Check all wiring connections to make sure that they are tight and secure. Make sure that all electrical boxes are properly closed and that all equipment is properly grounded. Test the circuit to verify that it is working properly. If you find any problems, correct them immediately. Remember that electrical work is not a do-it-yourself project for everyone. If you are not qualified and experienced, it is best to leave the work to a professional electrician. Your safety and the safety of others depend on it. In summary, while the NEC may permit a short run of number 14 wire to the light fixture under specific circumstances, it's essential to consider the entire electrical system and ensure compliance with all applicable codes and regulations. Always prioritize safety and seek professional assistance when needed.